Welcome to this explainer, where we're going to explore how human civilization has fundamentally transformed our planet's systems. If you just look around at our modern world, our cities, our farms, our giant industries, it's super easy to take the sheer scale of our footprint for granted. But today, we're really going to dig into the data and the history to truly understand what our presence means for the Earth itself.
Okay, let's dive right in by asking a massive question. Are modern human actions actually comparable to the asteroid impact that ended the Cretaceous period 66 million years ago? It sounds like totally wild hyperbole, right? I mean, an asteroid is an apocalyptic planetary scale event. But as we comb through the evidence today, I want you to keep this comparison in the back of your mind. Because the scope of human influence on this planet's chemistry, climate, and biodiversity is genuinely reaching a geological magnitude.
Section 1. Welcome to the Anthropocene, a new geological epoch.
To answer that massive question we just asked, we first need to look at a real game-changing concept proposed back in the year 2000 by chemists Paul Crutzen and Eugene Stoermer. They argued that humanity has actually entered a brand new geological epoch called the Anthropocene, which literally means the age of humans. Now, for thousands of years, we essentially lived within nature. We were pretty much subject to its whims. But this concept argues that modern industrial civilization has completely flipped the script. We aren't just passengers on spaceship Earth anymore. We've actually become the dominant driver of natural change.
So what's driving this? Well, we're basically overpowering nature through three huge systemic behaviors: burning fossil fuels at an unbelievable rate, transforming massive swaths of natural land for agriculture, and discharging huge amounts of synthetic chemicals directly into our air and water. These three primary drivers are literally altering the Earth's chemistry and climate as we speak. Moving on to Section 2, the Great Acceleration, from 1950 to the present. Historians actually use a super descriptive term for this unprecedented spike in human impact. They call it the Great Acceleration. To really wrap your head around it, consider this. Between 1950 and 2010, the world's gross domestic product, so our total global economic output, increased an astonishing 15-fold. That is an explosive, absolutely unprecedented leap in human productivity, wealth generation, and resource consumption. And the crazy part is, it was all packed into just a single human lifetime. But, that economic explosion came with a very real atmospheric price tag. In that exact same 60-year window, carbon dioxide concentrations in our atmosphere jumped from 310 to nearly 390 parts per million. To put that into perspective, using ice core climate records, that is a concentration of CO2 that the Earth had not reached in at least 800,000 years. It's truly off the charts. And driving both that massive economic growth and those skyrocketing emissions was an unprecedented boom in human life. The global population roughly tripled during that exact same time frame, surging from 2.5 billion people in 1950 to 7 billion by 2010. And obviously, more people meant more energy needs, more food requirements, and way more industrial output. You can see this explosive growth ripple across every single metric of consumption. During the Great Acceleration, water use from rivers and aquifers more than doubled. The amount of nitrogen we added to soils through synthetic fertilizers, that increased tenfold. And the number of motor vehicles on the road exploded from just 40 million to over 1 billion. When you look at all these metrics together, you can truly visualize why it's called the Great Acceleration. Which brings us to Section 3, the Climate Justice Divide and Distributional Injustice. Here's the really crucial point, though. All of this acceleration absolutely did not happen equally. We're faced with an incredibly stark distributional divide. On one hand, you have wealthy, industrialized nations like the US, the EU, Russia, and more recently China, who are responsible for the overwhelming majority of cumulative greenhouse gas emissions. But conversely, the nations most exposed to the physical consequences, like flooding, intensifying droughts, and severe cyclones, are disproportionately located in the global south and the Pacific Islands. These are places that contributed comparatively very little to the industrial emissions in the first place. And this brings us to a central, really tough ethical reality of the 21st century, perfectly captured by this phrase: those who cause the least harm bear the greatest cost. We're looking at a reality where small island states like Tuvalu, Kiribati, and the Maldives are facing literal inundation. We're talking about the complete loss of their national territories due to sea level rise. And this existential threat is caused almost entirely by the economic engines and emissions of other countries halfway across the globe. Let's look at Section 4, Global Climate Negotiations, seeking a global solution.
So, how is the international community trying to translate all this complex science into actual policy? Well, it began in earnest at the 1992 Earth Summit, and the global strategy has evolved pretty dramatically since then. If we contrast the Kyoto Protocol of 1997, which relied on strictly binding targets just for wealthy nations, with the 2015 Paris Agreement, it's a totally different approach. Instead of binding top-down targets, Paris uses voluntary nationally determined contributions, or NDCs. But importantly, it includes 196 parties, essentially the whole world, working toward a unified goal of limiting warming to well below 2 degrees Celsius. Now, to be perfectly impartial here, the Paris Agreement faced intense criticism from all sides of the political spectrum. Critics on the left argued that a framework relying on purely voluntary pledges was fundamentally just too weak to ever actually achieve that 2-degree goal. Meanwhile, critics on the right argued that the agreement imposed unfair economic costs on their home industries without placing strictly enforceable obligations on their major global economic competitors. And these domestic political disagreements have huge international consequences. The United States' participation in the Paris Agreement is a perfect example of this. They signed on in 2015, withdrew under President Trump in 2017, and then rejoined under President Biden in 2021. It just goes to show how incredibly vulnerable these long-term international agreements are to short-term domestic political changes. Now, we've talked a ton about emissions, but let's quickly define what greenhouse gases actually are. The greenhouse effect is entirely natural and absolutely essential for life on Earth. The crisis of the Anthropocene isn't that these gases exist, it's our radical, unnatural intensification of them through human activity. We're releasing massive amounts of carbon dioxide from fossil fuels, methane from livestock, and nitrous oxide from fertilizers, and we're basically just trapping way too much heat. Section 5. Beyond just carbon, looking at planetary boundaries. Because honestly, climate change is only the most politically visible dimension of the Anthropocene. There are other incredibly dangerous planetary boundaries we're crossing right now. One of the most urgent is biodiversity loss. Scientists are actually warning that we're currently undergoing a 6th mass extinction. Species are disappearing at 100 to 1,000 times the normal background rate. This is driven by habitat destruction for urban expansion and farming, the spread of invasive species, aggressive overfishing, and of course, climate change itself. And this matters immensely to us, because losing these species threatens the ecosystems that filter our water, regulate our local climates, and provide the genetic diversity we absolutely need for resilient agriculture. Furthermore, our oceans are taking a massive, mostly unseen hit. Because the oceans act like a giant sponge, absorbing about 25% of the carbon dioxide we pump into the atmosphere, they are becoming highly acidic. This ocean acidification is devastating. It threatens the calcium carbonate shells of plankton and corals at the very base of the marine food chain. And when you combine that with warmer waters, it is driving massive coral reef bleaching events all around the globe.
Finally, Section 6. Technology, problem, or solution, the ultimate test.
Ultimately, all these intersecting crises, the climate, biodiversity loss, ocean health, they all tie back to a really profound historical irony. Modern technology is the undeniable source of the problem, yet it is also our primary proposed solution. Fossil fuel combustion, massive industrial agriculture, and synthetic chemistry are what brought us to the brink. Yet we're now heavily relying on renewable energy grids, advanced carbon capture, and precision agriculture to pull us back from the edge. Which brings us to the ultimate test of the Anthropocene. I'm going to leave you with this final, really vital question to chew on. Can technological change actually be directed rapidly enough and, just as importantly, equitably enough to prevent the worst outcomes? Who actually holds the power to make these planetary-scale decisions? The Earth has been forever reshaped by our presence. The big question now is whether we can reshape ourselves to sustain it. Thank you so much for joining me for this explainer. Keep asking these tough questions, and I'll catch you next time.